In this video, we are going to detail an alternate way of calculating a cross product by using Sarrus's method, or the method of Sarrus. And the way that we approach this is we take our two vectors r and f. So again, we're going to try and find torque r cross f, and we're going to put it into a 3 by 3 matrix. Now you'll notice that there are two ways that that the method of Sarrus is approached. One is this horizontal method. One is this vertical method. I'm just going to do the vertical one because it's, I think, a little bit easier since it's already color coded. We're going to be using that one. So the first thing that we need to do, first thing that I'm assuming is that you've already looked at or are familiar with the other method of doing cross product, the one that we did in class. And provided you are, this is going to be a faster way once you get the hang of it. So what we're going to do to start with, let me go ahead and get a new pen, is I'm going to make my cross product into a 3 by 3 matrix. And so the first row of the 3 by 3 matrix is our unit vectors, I, j hat, j hat, k hat. The second row is going to be r, okay, in unit vector notation, 1, -2, 1. And then the third row is going to be f. In this case, I'm going to make it f1. And that's going to be 3, 0, and 2, as I've already written it. Okay, now what we're going to be doing, it's important that we do it in this order, r cross f. Okay, now in order to do Sarrus's method, once we have our 3 by 3 matrix, we're going to repeat the first two rows. I hat, j hat, k hat, 1, -2, 1. And what you can hopefully see at the, let me get myself a little bit more room here. What you should be able to see here is that all of these, basically the first, second, third row, we're slanting down to the right, and all of those you multiply them together and then add them as shown, and then you go from the other side and downward slant left, and you subtract all those values, and that's what we're going to do. That's what we're going to do here, and so. Let me find my cursor. Okay, actually I'm going to do it off to the right here. And so what we're going to end up with is that r cross f, so r cross f1 is going to be equal to, so if we start from the upper left hand corner, we have I hat, then -2, and then so 3, 0, 2. Actually, that's not 3, 0, 2, that's 3, 0, -2. Okay, and so -2 times -2, 4 I hat. And then we go down a row, 1, 0, k hat. So that since there's a 0 in there, nothing. And then we have 3 j hat 1. So that's going to be plus 3 j hat. And then we go from the other side and we say minus. You can see the first one is k, -2, -3. So that's minus -6 k hat. And then the next one is 1, 0 I hat. So that's going to be 0. And then the next one is -2 j hat 1. So that's going to be minus -2 j hat. Okay, and so we're going to add all those together. 4 I hat is just 4 I hat. There's nothing else. We have 3 j hat minus -2, so plus 5 j hat, and then minus 6 k hat, so plus 6 k hat. Okay, and so if we go to the previous one, you can see 4 I hat plus 5 j hat plus 6 k hat. And so that's doing it in the vertical method. Now, if we wanted to do, say, the horizontal method for the second one, which I will do, I'll do that one in blue, we would do something really similar to what we did before, and we would go I hat, j hat, k hat. This would be our r vector, which we already know, 1, -2, 1. And then this is going to be f2. Now f2 is -1 I hat. Actually, let me try that again. -1 I hat, 2 j hat, 0 k hat. And then instead of doing it vertically, instead of repeating rows underneath, I'm going to repeat columns. So I hat, j hat, and then 1, -2, -1, 2. And what I'm going to do now is I'm going to be looking at this horizontal method, and you can see kind of going down at an angle here. All of these three are going to be added, and then everything that's slanted down to the left is going to be subtracted. So that's what I'm going to now attempt. Find my cursor. It's the one downside about this writing tablet. So we're going to go R cross F2. And of course, remember, these are vectors. And I'm going to start with the upper left and work my way down. So I hat -2, 0 is going to be 0. J hat 1, -1 is going to be negative J hat. And then you have plus K hat 1, 2. Okay, and that's going to be 2K hat. And then we're going to work our way backwards, starting with the upper right hand J hat. So you can see J hat 1, 0. That's going to be 0, and then I hat 1, 2, so that's going to be 2 I hat, and then the last one, K hat times -2 times -2, which is +2, but since it's minus, 2K hat. Okay, so here you can see that we have our result, which is -2 I hat minus J hat, and the K hats become 0. If we go back to what we did prior, we can see -2 I hat, negative J hat, and then coming back here, our final thing is just to do our net torque, and so net torque is going to be equal to R cross F1 plus R cross F2, which is, I guess, torque 1 and torque 2, so torque 1 plus torque 2, which is going to be equal to 4I hat plus 5J hat plus 6K hat, not plus, but minus 2I hat minus J hat, and that ends up equaling 2I hat minus 4J hat plus 6K hat. There you go, 6K hat. And that's how you do Sarrus's method, both vertically and horizontally. My recommendation is to go back through one of your old homework assignments and attempt to do this method, and you'll notice it's pretty fast, and I would recommend it for quizzing and testing and stuff like that.